Hi, my name is Alex Keener, and today I'll be teaching you about colligative properties, which is basically a property that depends on the amount of the substance that you add, not necessarily the chemical property or chemical ID. So today I'm talking about the freezing point. Say I have two 1 liter bottles of water, and one I just keep perfectly the same, and one I add 100 grams of sodium chloride to. The freezing point of the one that the sodium chloride to will be lowered as the sodium chloride is going to increase the density of the water, which will make the freezing point lower. Now, if I added even more sodium chloride, the freezing point would become even more lower as the density would increase further because the concentration of the sodium chloride increase as well. So I can show this increase in decrease in the freezing point through this equation. So we got the change in the freezing point is equal to the Van Hoff factor times the freezing point depression constant, which for water is about 1.86, times the molality of the solute. So if I fill this in, it's going to be about 2. The Van Hoff factor for sodium chloride is going to be about 2 times the 1.86 times 100 grams of sodium chloride is about 1.711 moles, and then a liter of water is about 1 kilogram. So if you multiply this all together, we're going to get the change in freezing point is going to be 6.37 degrees Celsius. So we can subtract this from the original freezing point of water, which is 0 degrees Celsius, to get the new freezing point of about negative 6.37 degrees Celsius. So I actually did this thing with the two water bottles. I put them in our freezer, which is about 0 degrees Celsius currently. And as you can see, this is the pure water, and this is the water with the sodium chloride. And one is definitely more frozen than the other. So that just shows that the math works out, and that adding sodium chloride to water will in fact lower the freezing point. So thank you.